Welcome back. This is the second video in the series. It's kind of a companion series for our Khan Academy. This is where I, as a learner, am going through this with you and pointing out a few things to teach you as if we were together and I was standing over your shoulder making some observations. So, in our first video, we talked about what is program. We said, hello, world. We talked about pseudocode, how pseudocode is just kind of a layman's down and dirty way of writing down an idea of coding so that if you're sitting around with 5 people and they all know different programming languages, we can all just kind of talk about the general concept. And we're going to see an example of that in today's lesson, which is we're talking about variables. Now, we know that computer programs instruct computers how to process data. That's the important part here. Okay, so data comes from users sometimes, like when a game asks you to pick a difficulty level and music number. So imagine this computer and say, hey, what volume do you want? What difficulty level do you want? So those are inputs from a user. Other times data is already stored in the program. This would be in like the RAM or the ROM of a game. This is like when the game starts off with a score of 0 and 3 lives. This was stored as 1s and 0s, generally in the ROM. And I'm thinking like an old school Nintendo. If you were able to save your game, it would store it physically in the ROM. And what it's doing is it's just storing this information. Okay, so we've got a game. Here's our volume level. Here's our difficulty. You put those in. Here's our score. Here's how many lives you have. Okay, and that was already there for you. Either way, doesn't matter. The program can store the data in variables. Each variable has a name, a value, and a type. The value might change over time, and that's why it's called a variable. Okay, so the name doesn't change. We're not calling this volume for level 1, volume for level 2. We're just calling it volume. But the value might change. We might manually input it to go up or down. And we also have to tell it that it's the type of a variable is a number or a string. We'll get on those later. Let's talk about the values for now. Okay, this game is using at least 4 variables: volume, difficulty, score, and lives. Volume, difficulty, score, and lives. Okay, many variables store numbers and strings like the one above. Variables can also store other types of data like lists, dictionaries, and Boolean values such as true or false. We'll start by learning numbers and strings and dive into advanced types later. First, let's write some code. So, we're talking about assigning variables. Now, we're talking now about this in JavaScript. You're going to see at the end of this lesson how some other programs do this, and you'll start to see why it's kind of convenient just to talk in things in pseudocode. Okay, so in order for you to write a statement, that's what this is. This line of code is a statement. All programs are made up of statements, and each statement is an instruction to the computer about something we need it to do. Okay, so let's start with, let's go left to right. VAR stands for variable. You're going to write variables, VAR, then you're going to name the variable and set it equal to a number with a semicolon. Okay, so when we start up here, what was that score? With score. The score, we know it's a variable, it's a score, and we set it to 0. Well, that's how it's displayed, but this is how it looks like in code. Okay, now we're going to add our second variable, which was lives. We add variable, VAR, space. We give it a name, lives, equals, and a number. Semicolon closes it out. Now our code is using 2 statements to store 2 variables with 2 different values. Behind the scenes, the computer is storing each value in a different place in the memory, and the variables point to that memory location. So this is what it's doing behind the scenes. Notice the program is running here, and here's our code. So we said Variable, VAR for variable, and we give it a name, score, and we set it to a number, 0. That's why line 1 is that's why, well, you'll see in a second. Then we said our second variable is lives, and that equals 3. Now, if we had only written these two, we would not see these numbers right here. They would just be out there in the universe. But since we wrote these 2 lines, we can now see them over here. So we wrote, and I'm going to select these, and I'm going to cut them out of there. So look, variable score equals 0. Why are they showing up down here? Because we didn't tell the computer to display them. So all I'm going to do is a simple control paste to put them back in there. And that's why they're down here. So if you ever come across, man, I'm trying to put this piece of data or this information here, but I don't see it on the actual program. Did you remember to print the line that you actually have stored? Okay, so that's what it looks like behind the scenes. Remember, the print line displays it. There we go. When we instruct the computer to print line, the computer has to look in its memory for the current value of that variable. And once it finds it, it can display it at the console. Edit the code and ask the computer to find a variable it doesn't know about yet. What happens? Okay, so what it's asking me to do is, I'm going to print line, and currently I have score and live saved. Let's just make up one. Let me use my name. I'm just going to use Noah. Okay. Uh-oh. Noah is not defined. Maybe you meant to type norm or using a variable you didn't define. So what it's freaking out a little bit. It's saying, hey, go print the variable Noah. But Noah doesn't exist up here. Now, if I were to create a variable named Noah, set it equal to 33. Now, that would work. I just created a new variable and set it to a number. Okay? So, this command only works because I've got this data variable stored. Let's get back, reset it back to its beginning here. So, variable set, and now we're printing those two. Good deal. Reassigning variables. In a game, the player's score and the number of lives often don't stay the same. The score goes up and typically the lives go down. This means we need to be able to change the value of the variables later. We can reassign a variable to a new value using code similar to our initial assignment. Score equals 5. This is where it's written out here. Now, the score variable, this is where it started, is the value 5 instead of the initial value of 0. See it right here, 5. Notice that when we reassign in JavaScript, we no longer put the variable in front. That's not the case in all languages, so maybe slightly different in the future language. Here, a program that creates 2 variables, reassigns one of them, and displays the value along the way. So let's, you got to think about computer program also as starting from the top, reading left to right, and doing only what you're told to do so far without skipping ahead. Because that's what the computer does. When you hit run or debug, it starts up here and it goes all the way through. And it does it at the speed of light so that this displays it. So let's start at the top. We got a variable, its named score, we give it a 0. There we go. A variable, lives at 3. Then we told it, hey, print line score, print line lives, 0 and 3. Then we just added the word score equals 5. Now, print line score, and there it is, the 5. Now, what you may be thinking to yourself is, but I told it this is the score. How does it know which one to display, the 0 or the 5? Remember, it's starting Every time you run it, it's going to run all the way through all the instructions and do the most recent change, okay? The program is interesting because it contains two lines that look exactly the print line score. Print line score. Print line score. Yet, all of the outputted lines are different. How can that be? That's because the computer runs each statement in order, and the value of the score changes over time. So, this is what I was telling you about how a computer runs through, okay? And this is its logic. Step one. This is what we put in there. We named a variable score and set it to 0. This sets the score to 0. Step 2. Variable lives equal 3. Initializes the variable lives to 3. Good to go. Display, print line, display, print line, display. You're good to go through here. Now here's what's different. Score equals 5. So in the game somehow the score has changed. We don't have to write variable score. That will actually mess things up. We're just going to take our name, write it out, and set it equal to its new number. This reassigns the variable score to the value 5. And when we say print line score, displays the current value score 5. So it starts at the top and works its way down the bottom. When we're first developing a program, we often display the value of variables to double check the state of a program. Are the variables storing what we think they're storing, or did our code do something expected along the way? Okay. What I mean by that is, let's just play with some numbers. If I put 0 here, that changed this line, but it did not change the bottom line. The bottom line is the most recent score. Pause a second. This number changed right here because this is the program. Whichever one of these I changed, I don't remember now. Okay. Its print line is here for those numbers. This print line is for this number. So when I change this to 8, I expect this bottom number to go to 8. And there we go. Now, I think you understand variables fairly straightforward. Variables are data. They can be updated as we go. In JavaScript, we write them out var space, and then whatever name you give the variable, and then you set it equal to something if it's a number. That's all we've done so far. In order to see it, we have to say print line score, and that's how it works. But we're now going to mesh in our pseudocode. Okay? So pseudocode in general says a backwards arrow in the expression. When you see that as pseudocode, it means that the variable, which is a or whatever we're calling it, is assigned the value of the expression. For example, you might say this: age is 21, backwards arrow 21. This means the variable age is assigned to value 21. Let's look at the equivalent. If you were doing this in Java code, variable age equals 21, semicolon. If this was Python, age equals 21. Notice that they're not much different. Python is just a little smoother, a little more logical to our English language. Python's a lot newer, and the whole purpose of it is to be more intuitive. We'll start with JavaScript. And here is what it's like for block-based languages, which is like Scratch. We're going to be doing Scratch pretty soon if we haven't already by the time you're watching this. And so in Snap, you would say set age to 21. Okay? Up here would be variable age 21, so age and 21. And the app inventor would be this right here, which I've never used app inventor. So the whole point is that you can see the code to assign variables is very similar across all languages, but there's some nuance to each syntax. And so until you start learning 4 or 5 languages, it won't be as hard. But for now, just start with JavaScript and learn JavaScript. So let's check our understanding. What's the pseudocode equivalent for this JavaScript? Variable x equals 200. Okay. So as I look at this, I know that pseudocode, first thing I know is that the number is at the end, and I also know it's got the arrow. This does not have an arrow. This does not have an arrow. So I know those two are already wrong. So with the two that have the arrow with pseudocode, it was just the value. Our value is x. Variable x is this is kind of a blend between JavaScript and pseudocode. And that's not what we want. We just want the pseudocode. So x arrow value. Oh, I didn't choose it. Sorry. There we go. And hey, I got the correct answer. Okay. Let's do another one. Maybe. What's the pseudocode for this JavaScript? Variable of y equals -44. All right. First thing my process is I know it's got an arrow for pseudocode for a variable. So I know it's one of these two. And if I see variable y, that's actually JavaScript. So I know that pseudocode just wants our variable, like what it actually named it. So it'd be the name, the arrow, and then the value. So it'd be C. Hot dog. Okay. And that, my friends, is how we're storing data in variables. Hope this was helpful to you.